This is Mrs. Boots, and we're going to work through our practice problems from our simple factoring lesson. Remember, simple factoring means that the coefficient in front of the x squared is a 1. And so there's a shortcut that we can take instead of having to do the split the middle method on everything. First thing we want to do is find two numbers that multiply to give the constant. So number 1, what is the constant? The constant is 16. So I need all the numbers that multiply to give me 16. So what multiplies? Let's see. 1 and 16, right? 2 and 8, 4 and 4. So which of those pairs adds up? Remember, we're adding because it's a positive sign for the 16. Adds up to give us 8, the middle term. Well, that would be 4 times 4. So we put our two sets of parentheses with x's in the front. We put our 4's at the end. Now we figure out the signs. The sign of the 16 is positive, so they both get the sign of the middle term. So our answer is x plus 4 times x plus 4. Now, yes, you could write that as x plus 4 squared because there are two of them. Let's look at number 2. What is the constant? 10. Okay, so I need all the numbers that multiply to give me 10. Well, there's 1 and 10, 2 and 5. Well, that's easy enough. Which of those numbers add? Remember, the 10 is positive, so we're adding to get the middle term, which is 7. Well, that would be 2 plus 5. So again, parentheses, x is in the front, 2 and 5 at the end. The 10 is positive, so they both get the same sign as the middle, which means they're both negative. X minus 2 and x minus 5 is the factored form of this quadratic. Number 3. What's our constant? 144. So I need to make a table of all the numbers that multiply to give me 144. Well, obviously 1 and 144. 2, because it's an even number, 72. Let's try 3. Well, that would be 48. And if you don't have these memorized, that's fine. Just put them in the calculator. I have 4 times 36 and 6 times 24. And there may be some others, but we're going to stop there. We know there's 12 times 12. We could write that one down too, right? Okay. Now the 144 is negative. So that means I need to subtract to get 32. So I'm going to go with big numbers. 72 minus 2 isn't going to work. 48 minus 3 is not going to work. But 36 minus 4 is 32. So we write our two binomials, two sets of parentheses with x's in front. I'm going to have the 4 and the 36. Now it's a minus. That means that the bigger number gets the same sign as the middle. Well, the bigger number is 36. So the 36 would be positive, 4 would be negative. Because we're subtracting, they have to have opposite signs. So our answer is x minus 4, x plus 36. Let's look at number 4. What is the constant? Constant's 36. So we multiply to get 36. What multiplies? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay? Now the 36 is positive, so we're adding. Which one of those pairs adds to be the middle term? Well, that would be 6 and 6. 6 and 6 add to give us 12. So we write our two binomials. X is at the front. Numbers at the end, 6 and 6. The 36 is positive, so that means they both get the same sign as the middle term, which is 12. And yes, since they're duplicates, we could write that as x plus 6 squared. Number 5, 81. Well, that's kind of a big number, but that's okay. 81's our constant. Doesn't have any x's with it. So I got 1 times 81, 3 times 27, 9 times 9. Those are my factors. The 81 is positive, so which one adds to give me my middle term, which is 18? Well, that's 9 times 9. 9 times 9 is 81. 9 plus 9 is 18. And you're saying, but Mrs. Boots, it's negative 18. It's okay, we'll get there. So, binomials, 2 sets of parentheses. X is in the front, 9s are at the end. Both of my factors at the end. The 81 is positive. That means they both get the same sign as the middle. So they're both negative. And yes, since they match, you could write it as x minus 9 squared. It's okay if you write it out separately as x minus 9 times x minus 9. Let's look at number 6. What's the constant? 64. What multiplies to give me 64? Well, 1 and 64, 2 and 32, 3, nope, 3 doesn't work, but 4 does. I can do 4 and 16, and then 8 times 8. Now, 64 is positive. Positive means we add. Which one adds, which pair adds to give me the middle term, which is 16? Well, that would be 8 times 8. 8 times 8 is 64. 8 plus 8 gives us 16. So we write out our binomials. X is in front, and the 8s are at the end. The 64 is positive, so they both get the middle sign. Positive. The 16 is positive. Because they match, you can write it as the quantity 8 plus x plus 8 squared. Number 7. What is the constant? The constant is 12. So I need everything that multiplies to give me 12. That's 1 and 12, 2 and 6, 3 and 4. Alright, that 12 is negative, so I'm going to subtract to get my middle number. Well, if there's no number there, remember it's a 1. So 12 minus 1 is 11, that won't work. 6 minus 2 is 4, that won't work. But 4 minus 3, that gives me 1. So I write my binomials. X is in front, 3 at the end, and 4 at the end. Now we figure out the signs. The 12 is negative. That means the bigger number gets the sign. Well, what's bigger? The 4. So the bigger number gets the negative. Because the 12 is negative, I have opposite signs. So it's x plus 3, x minus 4. Let's look at number 8. What's the constant? 40. So I'm multiplying to get 40. Everything that multiplies to give me 40. 1 and 40, 2 and 20, 4 and 10, 5 and 8. Now the 40 is positive, so I need to add. Which pair adds to give me 13? That would be 5 and 8. They give me 13. So I write my binomials. X is at the front, numbers at the end, 5 and 8. The 40 is positive, so they're both going to get the same sign as the middle, which is a negative. So I have x minus 5 and x minus 8. Number 9. What's the constant? The constant is 20. So I need everything that multiplies to give me 20. Well, that would be 1 and 20, 2 and 10, 4 and 5. Did I miss any? No. The 20 is negative, so I want them to subtract to give me the middle term. So I subtract through 20 minus 1, 10 minus 2. 10 minus 2 is 8. Now we write the binomials. X is in front, numbers at the end. 2 and 10. Remember, the big number gets the same sign as the middle. So the 10 is positive. The 2 is going to be an opposite. Because the 20 is negative, the 2 has to be negative. So my answer is x minus 2, x plus 10. That is the factored form of the quadratic. Let's look at number 10. Well, this one's really easy. The constant is 9. What multiplies to give me 9? 1 and 9, 3 and 3. The 9 is positive, so I'm adding. Which pair adds to give me the middle term? 3 and 3. Those add to give me 6. So, I write my binomials. X is at the front, and in this case, 3's at the end. Now, the 9 is positive. That means they both get the same sign as the middle. So they're both negative. So it's x minus 3 times x minus 3, which I could also write as x minus 3 squared. Number 11. What's the constant? 4. Let's write it out. What multiplies to give us 4? 1 and 4, 2 and 2. The 4 is positive, so what is going to add to give me my middle term? Well, that's 2 plus 2. So we're going to write out our binomials. X is in front, numbers at the end. The sign of the constant is positive, so they're both going to get the sign of the middle term, which is negative. So I have an x minus 2 and an x minus 2. That can be written as x minus 2 squared. Let's look at number 9. What's the constant? Well, that's the 9. Remember, the constant doesn't have an x with it. This quadratic's a little different because there's only 2 terms. It's actually a binomial already. But we have an x squared, so we know we need to factor it. So what multiplies to give us 9? 1 and 9, 3 and 3. Now that constant's negative, so I'm going to subtract to get the middle term. Here's the question though. Where is the middle term? Well, the middle term is actually a 0. So I need 2 numbers that subtract to give me 0. And that's okay. You can have a 0. Well, 3 minus 3 gives me the 0. So now I can write my binomials. X is in front, 3's at the end. Just like before, because the 9 is negative, both of them have to have opposite signs. So one is plus and one is minus. It doesn't matter which one because they're both a 3. So my answer is x plus 3, x minus 3. This is also considered a special case, which is called the difference of 2 squares. You may have heard it in the past. Most teachers teach it separately because they want you to remember it. Both of these are perfect squares. Number 13. What is the constant? 25. Well, what multiplies to give us 25? 1 and 25, 5 times 5. The 25 is positive, so I need my terms to add to give me 10. Which pair adds to give me 10? 5 plus 5 adds to give me 10. So I write my binomials. X is in the front, 5's at the end. What is the sign? Well, the 25 is positive, so they both get the sign of the 10, which is a negative. So I have x minus 5 times x minus 5. We can write that as x minus 5 squared. That is the factored form. Now let's look at 14. What is the constant? 16. What multiplies to give me 16? Well, 1 and 16, 2 and 8, 4 and 4. The 16 is negative, so I'm subtracting. So I subtract and see which pair gives me the middle term. 8 minus 2 gives me the 6. So I write my binomials. X is in front, numbers at the end. There's a 2 and an 8. The bigger number always gets the sign in the middle. Because the 16 is negative, the other number gets the opposite. So my answer is x minus 2, x plus 8. Number 15. What is the constant? The constant is 3. Well, there's only one pair that multiplies to give me 3, and that's 1 and 3. So my 3 is negative. Does 3 minus 1 give me my middle term? 2. Good. So now we can write our binomials. X is in front, numbers at the end. I have a 1 and a 3. The bigger number is always going to get the same sign as the middle. Because the 3 is negative, the constant's negative, I know that the other factor has to be the opposite sign, which is negative. So I have x minus 1 and x plus 3. Number 16. What is the constant? 16. What multiplies to give us 16? 1 and 16, 2 and 8, 4 and 4. 16 is positive, so we want the numbers that add to give us the middle term, which is 8. 4 plus 4 gives me 8. Write your binomials. X is in front, 4 is at the end. They're both the same number. That's okay, because the 16 is positive, so they both get the same sign as the middle, which is a negative. Now I could rewrite this. What could I write it as? X minus 4 squared, because they're both the same. Number 17. What is the constant? 48. So what multiplies to give us 48? 1 and 48, 2 and 24, 3 and 16, 4 and 12, and then 6 and 8. Now the 48 is negative, so I need to subtract to get my middle term. Which pair subtracts to give me a 2? 8 minus 6 gives me 2. So I write my binomials. X is in front, numbers at the end, 6 and 8. Now the 48 is negative, so I know they're going to be opposite signs. But the big number is going to get the same sign as the middle term. So the 8 is positive and the 6 is negative. So my solution in factored form for this quadratic is 8 minus 6 and 8. X minus 6 and x plus 8. Number 18. What is the constant? 1. Yes, it is still possible. What multiplies to give me 1? 1 times 1. That 1 is positive. Does 1 plus 1 equal the middle term? 2. Yes, it does. So I write my binomials. X's are in front, 1's are at the end. What are the signs? The same as the middle. Because the constant is positive, they're both identical. My binomials are identical, so I can write my factored form as x plus 1 squared. Number 19. What is the constant? Constant is 18. What multiplies to give me 18? 1 and 18, 2 and 9, 3 and 6. That constant is negative. My 18 is negative. So I have to see which one subtracts to give me the middle term. 6 minus 3 subtracts to give me the 3 in the middle. So now we write our binomials. X is in front, numbers at the end, 3 and 6. The 18 is negative, so they have opposite signs. The bigger number is going to get the same sign as the middle. The other number is going to get the opposite sign. So my solution is x plus 3, x minus 6. That is the factored form. Number 20, 96. Yes, it's a big number, but that's okay. It has lots of things that multiply to get it. So I have 1 and 96, 2, 48, 3, and 32. We could keep going, but I noticed the 96 is positive. That means I need two numbers that add to give me the 50 in the middle. 2 plus 48 adds to give me 50. So I write my parentheses with my binomials. X is in front, numbers at the end. Because the 96 is positive, they both get the same sign as the middle number, plus and plus. So the factored form is x plus 2, x plus 48. Number 21, 120. Let's write the factors. Obviously, 1 times 120, 2 times 60, 3 times 40, 4 times 30. There is a 6 times a 20, and 10 times 12. We could have done 5 as well. The 120 is negative, so I need the numbers to subtract to give me the middle term, 26. So as I look down the pairs, which ones subtract to give me 26? 30 minus 4 is equal to 26. So I write my factors. X is in front, numbers at the end, 4 and 30. The 120 is negative, so they're going to have opposite signs. The bigger number gets the same sign as the middle. 30 is negative. The other factor or number is going to have the opposite sign. So my solution, or my factored form, is x plus 4, x minus 30. Number 22. You may look at this and think it's not simple because the number in front of the x squared is not equal to 1. Remember, earlier I gave you a hint. There's a special case called the differences of squares. This is one of my special cases. In my differences of squares, we take the square root of each of the numbers. So the coefficient of x squared is 9. Square root of 9 is 3. The constant is 16, and the square root of 16 is 4. So my factors, I write my parentheses. In front, remember, there's a 9, so this becomes 3x in the front. At the end where the 16 was, I have 4s. Because the middle is a 0, they're opposite signs. So I have 3x plus 4 and 3x minus 4. This is our special case differences of squares and the factored form. Number 23. Number 23 is also a differences of squares. The square root of x squared is x. The square root of y squared is y. So my binomials, put your parentheses. The x squared's first, so my x's go in front. Y squared second, so y's go at the end. Opposite signs. One is plus, one is minus. The solution is x plus y, x minus y. 24 is the same thing. The perfect squares and the subtraction sign give it away. The square root of 196 is 14. The square root of 9 is 3. Write the parentheses. The 14 goes at the front with the x. because that's where the 196 was located. The 3 goes at the end where the 9 was located. The signs are opposite because the middle term is 0. So my solution, or my factored form, is 14x plus 3, 14x minus 3. Number 25. What is the constant? 196. Let's do the factors for 196. 1 and 196 are always first. It's an even number, so 2. 2 times 48. Oh, 98. Now let's do 3. 3 times nothing. 3 doesn't work. So let's do 4. That's 4 times 49. And then 7 times 28. Now I have to look. The 196 is positive. So which pair adds to give me 53, my middle term? 4 times 49 equals, or 4 plus 49 equals 53. 4 times 49 is 196. So I write my binomials. X is in front, numbers at the end, 4 and 49. The 196 is positive, so both factors get the plus sign, the same sign as the 53. So my factored form is x plus 4, x plus 49. Number 26. 400. My constant's 400. Factors. 1 and 400, 2 and 200, 4 and 100, 5 and 80, 20 and 20, 10 and 40, and we keep going, 16 and 25. The 400 is positive, so I need numbers that are going to add to give me 74. 5 and 80 are the closest, but those do not add or subtract to give me 74. In fact, none of the factors do. So this answer is not factorable. This is a problem we would have to use the quadratic formula for, which we will cover in another section. Number 27. What is the constant? 81. So what multiplies to give me 81? 1 and 81, 3 and 27, 9 and 9. The 81 is positive, so I need my factors to add to give me my middle term, which is 30. 3 and 27 add to give me 30. Write the binomials. Parentheses with x's at the front, numbers go at the end, 3 and 27. The 81 is positive, so both factors get the same sign as the middle term, which is 30. So the sign will be negative. X minus 3, x minus 27 is the factored form for this quadratic. Number 28 is a duplicate of number 13. Number 29. What are the factors for the constant? The constant is 25. My factors are 1 and 25, 5 and 5. The 25 is positive, so they have to add to give me the middle. 5 plus 5 equals 10. I write my binomials with x's in front. 5's go at the end. 25 is positive, so they both have the same sign as the middle. The middle term is positive. So it's x plus 5 times x plus 5. Because the binomials are identical, we can write it as x plus 5 squared for our factored form. Number 30. What's the constant? 49. What are my factors of 49? 1 and 49, 7 times 7. The constant is positive, so I need the numbers to add to give me my middle term, which is 14. 7 plus 7 equals 14. Write your parentheses for the binomials. X's go in front, 7's go at the end. The 49 is positive, so both binomials or factors will have the same sign as the 14, which is negative. X minus 7 times x minus 7. Because they are identical, I can write this as x minus 7 squared. That is my factored form. Number 31. I see I've got perfect squares. The square root of x squared equals x. The square root of 36 equals to 6. There's only one small problem. The sign in the middle is a plus. This means it's not a difference of two squares, but the sum. And this is not possible. So number 31 is not factorable. There is no solution. We would have to use a quadratic formula to solve it. Number 32. I see perfect squares again. The square root of 16 is 4. The square root of 1 is 1. Is this a difference of two squares? No, it's a sum, which means it is not factorable. We would have to use a quadratic formula in order to find our factors. Number 33. I again see squares, perfect squares. 49, take the square root, is 7. The square root of 1 is 1. It is a difference, which means it's factorable. The 49 was in front, so the 7 goes in front with the x. So in my binomials, I would have 7x at the front. Then 1 is at the end. Square root of 1 is 1, so I have 1's at the end. Remember, the signs are always opposite in order to get the 0. So my factored form is 7x plus 1, 7x minus 1. Number 34. Number 34, I see perfect squares, but I also see a GCF. So let's pull out the GCF first. I can divide the 4 by 4 and the 36 by 4. When I divide the 4 out, it's the GCF. It has to stay in front. I'm left with x squared, and 36 divided by 4 is 9. So it's x squared minus 9. Now x squared minus 9, these are perfect squares. So I can then factor it. The 4 stays out front. I have x's in the front of my binomials. The square root of 9 equals to 3. So I have a 3 in the front and a 3 in the back. The signs are always opposite, plus 3 and minus 3. So my answer is 4 times x plus 3, x minus 3. Number 35. Again, perfect squares. The square root of 36 equals 6. The square root of 49 equals to 7. I don't see a GCF, so I'm going to go ahead and factor it just like it is. Write the binomials. What goes in front? The 6 goes with the 36, which was at front. So we have 6x in the front of our binomials. The 49 was at the end, so 7 goes at the end. Signs are opposite because it is the difference of two squares. So my answer for factored form is 6x plus 7, 6x minus 7. Number 36. Again, difference of two squares. What is the square root of 225? The square root of 225 is 15. The square root of 16 is 4. So I write my binomials. Parentheses. 225's at the front, so I'm going to have 15x at the front of each factor. The 16's at the end, so the 4's go at the end. Opposite signs, plus and minus. 15x plus 4, 15x minus 4. Now let's look at number 37. In number 37, we actually have perfect squares again. We have a 16 and a 10,000. The square root of 16 is 4, and the square root of 10,000 is 100. So we can write our difference of two squares. I'm going to have 4, but remember this is x to the 4th, so it becomes x squared with 100 at the end. 4x squared at the beginning, 100 at the end. We have opposite signs, 1 plus and 1 minus. Only there's a trick with this one. Notice I have perfect squares again. That 4x squared minus 100 can be factored a second time. The square root of 4 is 2, so I'm going to have 2x at the front. The square root of 100 is 10, so I'm going to have 10s at the end. One's a plus, one's a minus. I still have the 4x squared plus 100, and that stays. I could have pulled a GCF out of here, and I should have. The 2's can come out of the 2x plus 10, 2x minus 10, and I can pull 4 out of the 4x plus 100. So if I divide those, 2 times 2 times 4, that becomes, imagine that, 16. Okay? So this would be x plus 5, x minus 5, and then divide 4 into each of the last binomial, and I get x squared plus 25 with a 16 out front. This is completely factored. Number 38. Again, I have perfect squares. The square root of 81 is 9. So I would have 9 at the front. Now remember, x to the 4th becomes an x squared. So it's 9x squared at the front. Now what is the square root of y to the 4th? It's y squared. So I have y squared at the end of my binomials. Opposite signs, plus and minus. Just like on the previous problem, I now have perfect squares a second time. Square root of 9 is 3. The square root of x squared is x, and the square root of y squared is y. So let's put it together. We would have a 3x at the front of these binomials. Y's at the end with opposite signs. The binomial that's not factorable still drops down. It's still part of our answer. So you'd have 9x squared plus y squared. My factored form is 3x minus y, 3x plus y, 9x squared plus y squared. Number 39, last practice problem. Also perfect squares. The square root of 625 is 25. The square root of 16 is 4. So let's put that together. 625 is at the front. So we would have a 25. The y to the 4th, when we take the square root, becomes y squared. So I have 25 y squared at the front. The 16 became a 4, so I have 4's at the end. The z to the 4th becomes a z squared. Now one sign's positive, one sign is negative. Next step, I have another perfect square that I have to split up. The square root of 25 is 5, and the square root of 4 is 2. So I have 5y minus 2z and 5y plus 2z. Notice the 5y's are at the front, the 2z's are at the end. One sign is plus, one sign is minus. I still have to bring down the other factor. 25y squared plus 4z squared. This is my factored form for number 39. And this concludes the practice problems for this lesson.